Hi, I'm DJ Ware. On this episode of the CyberGizmo, we're going to be continuing on with the Linux hardening for the home machine. And this will be part 3, right after this. So I think last time that we left off, I think our score was 82 on the machine, and so we probably won't increase that appreciably, maybe a couple of points, but we'll see what we end up with. But the things that I'm going to do today is first make sure that we have an updated system, because Linus will look at that and it'll flag it if we're not. Second thing I want to do is I want to turn on something called system accounting. And system accounting dates way back into the early days of Unix. I mean, if you want to know what's going on in your system today, we just do top or htop, and we can get a nice list and we can collect all this nice information in real time. But SAR does it over time, collects this same kind of information and preserves it over a 24-hour period, and then you can generate reports for that to establish trends and what's going on with your machine. Why is that useful? If you have been breached, and let's say your machine is being used to mine cryptocurrency, you would see an appreciable load on the system from what your historical loads have been. And so that would be a trigger, for example, that, hey, I've got something going on that I haven't seen before. So that's why you want a system accounting. Also, it'll tell you information about, how many times something's been written to disk. And in the old days, the old SAR reports would actually produce a list like you see here, where you have the tasks that were running in a given time frame, and those would then show you, what was going on during these various intervals during the day. So for this hour, I had this set of tasks running, and for that hour, I had this set of tasks running. So anyway, let's do that. So I need to get into this, and we'll do an APT. I just want to make sure that, did I do it? Let's make sure that we're updated first. I might be doing this twice, but that's all right. And we are. And so now we'll do an APT install on sysstat. And I've already done it, and so you'll have to do it as well. The next step you'll want to do is a system control enable. But don't start it yet. There's one thing that you'll need to do. You should find a file in here called sysstat, and in there will be this enabled equals false in your case. So you'll want to change that to 2, and what that tells it is for SADC, which is the parent process, the system accounting daemon collector, data collector, if you will, and that will then show. That will then start collecting statistics for us to be able to report on. So you'll need to change it to true. If you just start it up without having this enabled, well, it isn't going to collect any statistics. So your reports will be empty. And you'll go, why are my reports empty? And that's why. So then we can do once you've done that, you can go ahead and start it. And then we'll check the status. And it's running. Now you might want to wait a while on yours. Mine's been running for a bit, but generally what will happen is that on your machine you'll see these lines. You may not get any of this yet because you haven't had enough time yet for the system to actually start collecting. There are cron jobs that get installed, and they periodically will dump the collected statistics out of SADC, and so it'll record them into a SAR. I think it's a SAR2 file that's in your var logs. And this one is kind of similar to top. It's giving you information about the CPU and the process load that's on it. And we've seen this kind of before. I've talked about this in some of the performance videos. But I'm going to go down here, and now we'll see processes per second and context switches per second. Context switches have to do with switching pages in and out of memory. So it has to save state. It means that it's the kernel is having to bump something out of the kernel cache, out of the processor cache in order to accommodate a new process switch. Or it could be your program, your application itself is larger than that will fit, and there's a branch in your application that's in a page that isn't resident. So it has to do a context switch to load it, meaning it saves its work, pulls the new page, starts executing, saves that work, pulls the new page, and starts executing. These are your page ins and page outs. And there's more statistics about those. You'll see faults here. That's pretty high for that. Probably some of the stuff we were doing during the updating period today. So yeah, and then it goes down through some of the other kernel statistics. Then it goes into the devices, and these are transfers per second, and then read kilobytes, write kilobytes, and so forth. These are starting to collect some data here. Then it goes in and starts looking at your network and does kind of the same thing. It looks at the number of and then you have system overhead, system calls, S calls, and all that kind of stuff that's going on with the network. And then you have UDP, TCP, hits, miss, all that stuff. Yeah. Now, like I said, I think I'll have to come back and explain that one on how to get, if I can, how to get the actual task names to show. Because if I can, in there it'll show what user was running it at that time, and you'll have an idea what's going on. So why is this useful in a security context? What would you use that for? You use it to establish a norm, because if I'm doing the same thing on that server day in and day out, the process load shouldn't vary unless the transaction load changes, right? So I should see some scaling that's going on within the application space that's running. But, that's going to be normal peaks and valleys as you have user load come on and go off. But if I start seeing something that's strange, and start seeing, maybe some activity that looks like Bitcoin mining, and I didn't put any jobs to do Bitcoin mining on my machine, that might indicate your machine has been used for some nefarious purpose other than what you had intended for it to do. So anyway, so that's sysstat. And there are crons that are established to generate reports daily. And so you can go do that. But you can also do the reports manually, like I just did, a SAR-A, which is basically a conglomerate of a whole bunch of different commands lumped together. I mean, Linux and Unix both kind of did that, where it would just, instead of having to put a capital B and then a C and then a D to get all the stats, they had a -a command, which kind of lumped things together. So, all right, so this explains kind of what it does. Yeah. And then there's -a, and you can see that all this stuff right here is the -a command. So you can read individually about what they do. If you aren't interested in all that, you can just select out the information that you're interested in on the report. And like I said, these will do it for the current period. Now, once a SAR has closed, that data isn't available to you anymore unless you give it a file name that you want to go back and look at historical data. But it will create a SAR report for that activity for that particular day. That's the default behavior. And of course, you can change your crons to make this run however often you want, how often to dump and consolidate the statistics together. So yeah, anyway. Yeah, once it doesn't hold all that data in the collector forever. I mean, it's got to dump it at some time and move on. So, all right, so that's number one. We've talked about how to collect information on the system itself. The next thing we want to do is we want to turn off the ability to do system dumps. And so there's really a couple of things that we want to do here. One is we want to set a limit on the system in order to disable core dumps. We need to set a ulimit value. And that's done in the securitylimits.conf file. So that's the first thing we want to do. And there are both soft and hard limits. A hard limit is something that a user cannot override. So if I set a soft limit, they can override that. So, and that defines some specific shell restrictions. Again, if you're on a development box, you're probably not going to want to do this because you're going to want your dumps in order to figure out what's going on. I don't know. Maybe you don't read core dumps. Maybe you do it some other way. But and they are a useful tool. So the first thing is we want to ensure that no process can create a core dump. And we can set both the soft and the hard to 0, or we can just set the hard to 0 and that does it, period. So so let's go do that first. I hope that was. So we're going to edit a file called limits.conf, and this is in the directory etc security. And I'm going to go all the way down here to the end. Now in yours, it'll probably be commented out. It'll be a £, in front, so you'll want to undo that. And then the default is soft. So change that to hard. Change the item, which is core dump, to 0. That says that you will not generate any core dumps at all. And the user can't change that to 10 or 3 or 1 or whatever. So yeah, 0 is false, 1 is true. Okay. So that's done, but that's not the end of it. The next thing I have to do is edit my syscontrol conf file, which is in /etc. And I'm looking for something called fs. Oh, come on. There we go. fs sudo set uid dumpable, and I want to make sure that that's explicitly set to 0. And that's saying that a user can't set UID, become root, and turn the core dumps back on. So yeah, and I'll need to actually reread that file and pull that in if you don't have that already in yours. Finally, one other thing I need to do. I'll need to prevent the user from being able to change the limit. So this again is setting the core dump to 0, and then it outputs dev null, so it doesn't clutter up your logs when the U limit is set. So this prevents a user from being able to do a set UID and then become root and change the core dump and the value. So there's also some things you can do in systemd. I think I'm going to probably wait on those and talk about those when I get into systemd more, because that's really going to be a topic in and of itself. So I'll go ahead and save that. Then the last thing I want to talk about today is being able to change permissions. So we'll want to make sure that we have at least the ones that Linus is looking at. Now, of course, what permissions your system runs at with your applications, that is not, Linus wouldn't know that, right? So that if you've got specific things that you're trying to protect, then you'll want to have your permissions set for your applications. This has nothing to do with that. This is not the end all be all. This is the only thing you have to protect. I will tell you that if you that the number one cause of errors in Linux, I will guarantee you, is permissions. So if something doesn't run, something breaks, doesn't start up, chances are the first thing you should look at is permissions, because that's the most common thing to prevent an application from coming up. So anyway, that warning aside, I have a perm set already here, and I'll put this in my GitLab. So these are the files that Linus looks at. It looks at cron tab, and it wants it set to read-write just for the user. Same for the ssh/sshd config file. Once that's set to rewrite for user only. Cron D, read write execute, user only. And the same for cron daily, cron hourly, cron weekly, and cron monthly. Then you get down to home, and it wants read write execute for the user, but read write for the group, and then, or I should say read execute for the group, and then no permissions for the world at all. And so, yeah. So we'll go ahead and we'll run that. I have to be sudo to do this, and no news is good news. So if you don't see any errors, it did it. So that's the way. Yeah, because let's see, cd ls minus l/s. Yeah, okay, so read write, it did it. Let's check home. Yeah, it did that too. So we're all good to go there as far as I know. And I can, let's go ahead and do all those. Yep, all good. So that's done. And that's the three things I was going to cover today. So let's go back out to opt Linus and let's see where we ended up. So there's one right there. It's turned green. Is sysstat accounting data while we're waiting for it to look at cryptography. So that's now, it now recognizes that as being enabled. Let's see. So these are all the kernel hardening, and those are all okay. You don't have any errors there. Home directories are all in the green. And then the file permissions now are all in the green. Now let's see what we got. We still have 20 things we need to work on. But the list is getting shorter. We're at 84. So that's where we're at today. So I think that's where I will stop. I don't want to, I don't want to create some kind of overload condition where we go through every one of these things because we'd be here and then you forget what I was saying. But so those three things you can work on for this week. And then next week we'll get into the grub permissions, setting up the user ID and password for that. So, and now one thing I will say on grub, if this is a system that runs headless, you're probably not going to want to do that because it's going to be sending it to the console and it's going to be sitting there after you restart the server. It's going to be sitting there waiting for someone to walk over to the console and enter the password. So you probably don't want to do that on a headless. So anyway, I hope you enjoyed this today. If you did, please like and subscribe. Hope to see you all next week, and have a safe and happy holiday if you're in the U.S. And hope to see you all again real soon. Bye for now.